All right. So far we have Prisha, Aryan, Deep, Sunarka, Vishal, and Rehan. So, did you guys get a chance to see what are the topics that we are going to cover today? Hi, Chris.
Hi, sir.
Okay. So, I'll quickly read the topic that we are wanting to cover today. And I have posted few sample questions that we'll try doing it together. So that way, it's just not about theoretical knowledge. It's about how do we apply understanding of things for solving problems. Or the kind of problem that you guys will come across in your test. So what we're going to cover today are basically how do you manipulate quadratic equations and polynomials, and we have a couple of examples for that. We'll try solving those. Exponential graphs and their features. So basically, we have looked at linear equations. We have looked at quadratic equations. We have tried plotting them, and we have seen what kind of shape it kind of gives birth to. And then today we'll focus more on exponential graphs and understand their features, and then how do we relate that to understand the features or the behaviors of the graph better. What do we mean by horizontal and vertical asymptotes? How do we relate to that? How do we find it out? And then how we can move the horizontal or vertical asymptotes by manipulating the equations for the exponential graphs. So let's see how much we are able to cover today. Whatever is remaining, we'll come to that tomorrow. So in summary, if you look at it, we are primarily trying to see how do we manipulate exponential equations or quadratic equations. Hey Dave.
Sir.
So we'll talk about how do we manipulate exponential equations, and then we'll look at exponential graphs and equations, and there are some of the key features that we need to be aware of. And when it comes to manipulating them, how do we do that? Alright, so let's start with the manipulation of some exponential graphs, and I have posted some questions. So let's look at those questions and see what would be our approach for solving it. Let's look at one of the questions quickly. And I know you guys are tired of me, but we'll apply this whenever we are trying to solve any problem. Okay. So this part I will skip, and I'll start with the D part of it. The first question says, the graph of y equal to 3x squared minus 12x plus 9 is shown. Y equal to 3x squared minus 12x plus 9 is shown. If the graph crosses the y-axis at the point 0, k, what is the value of k? So I'm just writing it down. The graph of y equal to 3x squared minus 12x plus 9 is shown below. So this is shown as, this is the graph that you see, okay? And this is x-axis, this is y-axis. If the graph crosses the y-axis at the point 0, k, so let's say it crosses the y-axis at 0, k, it is asking us to find out the value of k. This should be an easy one. So somebody joined quietly when I was focusing on the question, so that is Sarah. Hey Sarah. Where is Neil?
He's not feeling well.
Oh, okay. I hope that is not because of me. Okay. So coming back to a serious point. So what I'm saying is this is a question that we're trying to solve. And this is one of the standard questions that you guys will come across, which says the graph of equation y equal to 3x squared minus 12x plus 9 is shown below, and it is touching the y-axis at point 0, k. Find out the value of k, and then you are given few options here, which is k, a is 3, b is 4, c is 9, d is 12, and you have to pick one of the answers. First thing first, when you look at this equation of the graph, I'm still focusing on this one, R part of it. I'm just reading it again and again. It says the graph of this equation is shown below, and which is intersecting the y-axis at point 0, k. Find out the value of k. And these are four options we are given. So when you read this question along with me a couple of times, you would have realized, okay, this is a quadratic equation which is plotted here, which is intersecting y-axis at this point 0, k, and intersecting y at 0, k. It's very normal, right? Whenever any graph intersects the y-axis, meaning on this axis anywhere, if any of the graph or line intersects, the x coordinate of that will be 0. That we already know. So that's why it's 0. So we just have to find out this length, which is k. If we have to find out the coordinates of these 2 points, first thing you will keep in mind is the y value of along this line is always 0. Y coordinate along this line is always 0. So this, based on whatever we have learned with respect to the equation of parabola, we know that this is called y-intercept of the parabola, meaning where the y-axis is the parabola is touching the y-axis. Since this is a quadratic equation, it is a parabola which is facing upward. And again, we know that, okay, if A is positive, it is facing upward. These are things that we already know, nothing new, right? So I'm just repeating myself. I have not started solving this problem yet. All the information we have collected or we are aware of, we are just accumulating that to think through it. So we have equation of a parabola, which is plotted here. This is where it is intersecting y-axis, or we have been asked to find out the y-intercept, basically. So from this, again, this is the equation for a parabola, meaning any and every point on the parabola will abide by this contract. Yeah? Hey Chris. Everybody with me, right? I'm not rushing for solving this problem. That you can clearly see. I'm not in a hurry. Because this is my formula, which I'm forcing you guys to believe in. So that's why I'm not going to this one step. I have read this question enough and I'm doing the analysis right now. Okay, this is a parabola, y-intercept. Okay, and we know that y-intercept, if this is the equation, that means each and every point in the parabola will abide by this contract. So would this point. And I already know what is the x value of this point. So here the x value is 0. This is going to follow this line. So that means if now I'm jumping to the part n. I have read the question enough. I have done enough analysis. I have recollected everything that we know. And now I'm trying to solve this problem. Yeah. So this point is going to align with this one. So whatever change, okay, fine. So x value is 0 and y value is k. Let me substitute that in the same equation. Y value is k. I don't know what is k. I'll just put y as k. My x value is already known to me, 0. 3 into 0 is square minus 12 into 0 plus 9. Is there anything complicated about this equation or this question itself? Anybody? See, k equal to 3 into 0 is 0 minus 12 into 0 is 0 plus 9. It's black and white, straightforward. If we ever go wrong with this question, this kind of question I'm saying, then that means it's not you who is making mistake. It is me who has forced you to not focus on this. Just because I've kind of reiterated myself so many times and literally forced you guys to believe in this, as long as you don't rush for solving it, you cannot go wrong. That's my point of view. Now, I will take a pause here for 10 seconds and see what is everybody's reaction. Do you guys agree to what I said, or do you think that this question is at all difficult? Yes, Sunarka.
Oh yeah, sorry. I meant to say yeah, like I agree.
I'm sorry?
I meant to say yeah, I agree.
You agree? Wonderful. Now, see, and that's a very generic statement I would always put. There is not even a single question that you will come across that will be difficult. It is us who make it difficult. So my request to each one of you, including myself, is never make any problem difficult. Our attempt should be to make the question simpler. Everybody with me? Okay. Now, see, as I said, every question is simple. Now I will force you guys to believe that by doing one more problem. And this time, I have not solved these problems, okay? Trust me, I'm not bluffing with you guys. I have not even tried solving any of the problems. I randomly picked some questions just to reaffirm that the approach that I'm giving you guys is foolproof or reasonable enough. Let me read this question for you. Again, trust.
Let's remove this T from our life completely. Okay? We always ran and we ran successfully. That's what we'll call it.
Okay? I mean, if you don't trust your teacher that your teacher can do math, or you don't trust yourself that you can do math, we are not in the right place there. Yeah? So let's take T out of the equation completely, forever. I'll not talk about tran, I'll always say ran. Now, that makes it less boring. Now let's look at the next question. Which of the following is an equivalent form of the equation of the graph shown in the xy plane, from which the x-intercepts can be identified as constants in the equation? Okay? Sounds interesting, sounds a little difficult to begin with. So let me first plot this, so that way you'll be able to relate to what I'm reading here. Okay? 1, 2, 3. This is minus 3, and this is 1, 2. This is 2, and this is 1, 2, 3, 4, 5, 6. This is minus 6. So this says the graph is coming from here, crossing this line and going this way. Okay? So this is your y-axis, this is your x-axis. Why I put this? This is intersecting the x-axis at plus 2 and minus 3. That's why I have plotted those numbers here, so that you can visualize this. Now I'm reading the question one more time. Which of the following is an equivalent form of the equation of the graph shown in the xy plane? So this is the graph shown in the xy plane. And we know where it is intersecting. Where it is intersecting the y-axis also. Okay? And the equation of parabola is also given as y equal to x squared plus x minus 6. So this is what is given to us. This says, which of the following is the equivalent form of the equation of the graph shown in the xy plane, from which the x-intercepts can be identified as the constants in the equation. So it says the x-intercepts can be identified as the constants in the equation. So this is the graph that is given to you, where you can see the x-intercept and the y-intercept, and this is the equation for this one also given. We have been asked to find out that there are few options given to us. Let me write it down.
First one is y equal to x into x plus 1 minus 6. B says y equal to x plus 1 by 2 squared minus 25 by 4. C says y equal to x minus 3 into x plus 2, and D says y equal to x minus 2 into x plus 3.
Okay? So it says, now I'm reading the question for one last time, okay? It says, which of the following is an equivalent form of the equation of the graph shown in the xy plane, from which the x-intercepts can be identified as constants in the equation? So from this one, your x-intercepts can be identified as the constants in the equation. So now, if you guys recall, when we looked at any quantity equation, y equal to x squared plus bx plus c, this was one form, which is called the standard form. Our second form was called the intercept form, y equal to x minus a into x minus b. Okay, where a and b turns out to be our intercepts, meaning when y is 0, either x minus a equal to 0 or x minus b equal to 0. This turns out to be our two intercepts. So these are called the intercept. It is termed as x-intercepts as constants. So here these intercepts are your constants A and B. So this is the graph given to you, and this is the equation for this also given to you, saying that find out one of the equation that is equivalent to this one, to this equation, which is represented in the intercept form. X-intercept as depicted as constant. So it has to be in this form, something into something where x minus a into x minus b. Now a and b values are constants. So that's why we have to find out in this form. So when you look at these equations, okay, first of all you will look for the equivalent equation, the factor form. That is called the intercept form. So this one you will rule out blindly. You don't want to waste your time looking at this one. Okay, this is not intercept form. So what is the case with this guy? This is still not in the intercept form. You will rule out these two for now, and then you will look at these two equations to see what is the right answer based on how you are going to solve it. So now, so far if you look at this method, we read this question so many times, we understood that this is the graph and this is the equation for the graph, and we see the intercepts, x-intercepts and the y-intercepts. We have been asked to find out the equivalent equation from these options that we are given, which can show the x-intercepts as constants. So as soon as you relate to what we know, you know that okay, these two I would want to rule out. These two cannot be my options. So out of the 4 options, you have already ruled out 2 without even trying to solve it, right? So by reading it and by analyzing it, you know that okay, I don't want to waste my time for these 2 options. That is that. Is this part clear to everybody so far? Yeah? Sarah, no response? Okay. Clear, beta?
Yes.
Okay. Now I'll keep on asking everybody, right? So, I mean, I'm just trying to make sure that I'm not rushing through it. Deep, are you okay? Yep, okay. Now, without trying to solve this problem, we have got 50% of the answer already. Now what you want to do is, you have the equation, you know that okay, intercept form if I'm talking about, I'll not even try solving this problem. If I look at this one, what are my x-intercept and y-intercept? X has 2 intercepts where x equal to minus 3 and x equal to 2, or I'll write it here. And what is my y-intercept? My y-intercept is minus 6. When I use these 2 intercepts and I just apply it in this form, what is the possible answer I'm supposed to get? I'm just blindly putting it, okay? I'm not even comparing with this equation so far. If I just blindly put this, one is minus 3 and one is 2. So if I try putting it here, it becomes x minus 3. So minus into minus becomes plus, x plus 3 times x minus b. This is the second one, x minus 2. This could be a potential answer for this one. So when you look at this, x minus 2 into x plus 3, this seems to be the answer. This does not. But before we jump to the conclusion, ultimately this equation has to convert into this form. If I kind of explode this or break these 2 brackets open, if I get the whole value equal to this, then only this is the equivalent of that, right? So now if you look at this, it becomes x into x squared, x into minus 2 is minus 2x plus 3x, 3 into minus 2 is minus 6. So this becomes plus x, so it becomes x squared plus x minus 6. Matched. So, if you look at the whole thing, we did not do any complicated calculation. When I was reading this question for the first time, I was a little worried, okay? I was thinking that, okay, I have not solved this problem. I might go wrong. The answers that I have, these look very complicated. If I would have put effort for breaking it down, or breaking this down, and done the calculation, I would have wasted a lot of time. But as soon as it rang the bell to me saying that, no, we are talking about x-intercept as constants, that quickly gave me the clue that, okay, I have to look at the intercept form of the quadratic equation or the factor form of the quadratic equation. So my standard factor form is like this. And this, remember this AB and this AB are not the same. This is just a representation here. Okay. So I had to get in this form. So as soon as I looked at all the options I had, I could just eliminate these two. Then we were left with only these two. And now this was a little tricky. This and this looks very close. Okay. You might get the same answer. I mean, by looking at it. But without worrying about it further, we said, okay, fine. Now by looking at this graph itself, I see that, okay, these are my two x-intercepts. If I use that understanding and substitute the value here, what do I get? So instead of solving from here and coming to this, we went in the reverse direction. And that gave us a point blank answer, basically. Yeah? And we just have to verify this, that, okay, fine. Let's do one last round of validation to make sure that this equation's overall value is not different from this one. You could have, I mean, if you are more confident than me, you could have said, okay, I'll stop here because I know what is intercept form and I clearly see the intercepts. Right? But then there is no harm in spending 30 more seconds just to make it open and compare it. Now we have zero doubt about what we have done. If you would have assumed, then you have to pray hard. Are you with me? Is this approach sounding reasonably okay or acceptable? Now a very, very, what do you call, candid question. Did we learn anything so far? No, my question is, did we learn anything so far? Yes or no? Thumbs up might not do. You guys are very shy. And trust me, I don't want you guys to be shy. You have to just say that no, we did not learn anything. We did not learn anything, trust me. We have not learned anything new. What we are doing is we are just organizing ourselves to make sure that we do it right in the first go. That's it. Okay? And I would not call that learning. This is more of a practice that we are doing as a group. Yeah? Do you guys agree? You don't? Okay. Alright, so this was another question that we looked at. I had put, I think, two more questions. We'll probably solve one and then we'll jump on to the exponential equations. Okay. So let me read the next question. Oops. And
I should not have removed this, but now I'm trying to memorize my revamped formula.
that is called RAM. Okay. So let's go back to the next question. This question says the graph of y equal to 2x squared minus 4x minus 4 is shown in the xy plane. So let me show you the graph first, otherwise I'll be talking in air. So this is the graph. This is my xy plane. And this is probably 1, this is 2, I mean minus 1, minus 2. And this graph is,
And this is 1, 2, 3, 4. This is minus 4.
and this is
1, 2, 3.
so this graph is going from here
And 1 is somewhere here, okay?
it comes here,
Crosses 4, goes down, then goes up, and let's say 3 is here, okay? This is 3. I'm just. So this says, this is 1, this is 3. 1, 2, this is minus 1, minus 2, and this is minus 4. This is the
point where it is intersecting this one.
So it says the graph of y equal to 2x squared minus 4x minus 4 is
Shown in the xy plane.
so this is the equation
And this is shown here in the xy plane. Which of the following characteristic of the graph is displayed as constant or coefficient in the equation as written? So the options are given as
A is x coordinate of vertex, B is y coordinate
of vertex,
C is x intercepts, D is y intercept.
okay. Now, so far, I am more confused than you guys because I've just read this question once. Let me read it one more time. The graph of y equal to 2x square minus 4x minus 4 is shown in the xy plane. This is the graph shown in this plane. Okay. Which of the following characteristic of the graph is displayed as constant or coefficient in the equation as written? Now it says, which of the following characteristics of the graph is displayed as constant or coefficient in the equation as written? So here it says, which characteristic is displayed as a constant or coefficient in the equation as written? So here it says, this is your equation, and it says from whatever you see here, which characteristic is displayed as a coefficient or constant in the equation.
So which one is constant? This one is constant. What are the coefficients? This and this are the coefficients, right?
By looking at this graph, one thing that you can observe here is,
What is the x-intercept?
what are the x-intercepts?
Something little more than -1. Yeah. X-intercept is little more than -1 and little less than 3.
Yeah. Now, what is the y-intercept here?
It is intersecting at minus
4.
So this is the y-intercept.
So basically, x-intercepts are these two, y-intercept is this. So far we have only seen this one. So we read the question again, it says, this is your equation, the other options, says, just by looking at this graph and the plane here, what is displayed in the equation as coefficient or constants? Now, if you look at 2 and 4, we don't know. This is certainly not the intercepts, right? But if you look at this, see, you will not pick minus 4x as this thing because here minus 4x is 0. So if you put x equal to 0, this place doesn't hold true. But then if you put x equal to 0, what do you get? Y equal to -4, which is your y-intercept. So in this equation, the constant, the coefficients are not giving you any clear clue, but your constant is telling you that this is my y-intercept. The constant, the last term, is telling you that this is my y-intercept.
What is clear here? Y-intercept.
Now, the first two options were x coordinates of the vertex. We don't know whether it's 2 or 4 or -4 is the x coordinate of the vertex. So is the case with y. It's certainly less than -4. So none are holding true here. So vertex you will ignore. Now you are only looking at x-intercepts or y-intercepts. X-intercepts are not clear because you know that it's less than 1 and more than -1 and less than 3. So these constants are not aligning with any of these three. Only thing that is giving you a very clear clue is y-intercept because this constant is mapping with your y-intercept. Is that really making sense, or you guys are as confused as I was in the beginning of solving this problem? Do you guys want me to read this question one more time? Prisha, Chris, Aryan, Dave, Sunarka, anybody? Sarah? Clear?
Yes, sir.
Okay, alright. So the thumb rule that we all have to follow is any question and every question that you guys come across, trust me, nobody is your enemy. Nobody will give you questions on master's math in your city exam. So be assured that you will get only questions that you are supposed to get. Now, whether those are easy or difficult is a function of how we are approaching those problems, how we are managing time, how we are making sure that we are doing the right reading and analysis of the question before trying to solve it. Okay? And remember this one thing, don't keep that plan of getting a perfect 800 in your SAT exam in maths, okay? Because if you overburden yourself that, oh, I have to get a perfect 800, you'll kind of spend a lot of energy just stressing yourself out. Think that, okay, if I make 2 mistakes, it's okay, I'll still get 790, 785, okay? Shoot for that. And if you don't keep that stress with you, you'll end up hitting 800, okay? So don't keep target 800, keep your target low, little low. Say, okay, fine, I have the luxury of making 2-3 mistakes, okay? Sky will not fall if you get 785. 785 is a great score. Keep that as a target so that you are taking out your stress during the exam. And then do your best, and I'll be more than happy when I see most of you getting 800. I mean, that's my dream, okay? That's what I'm working towards. So, people always say, keep your target high so that you will get something less than that. I say it the other way around. If you keep your target as the highest possible marks, you're actually stressing yourself out. That, no, if I miss one question, my whole career will go for a toss. No, it is not that way. Does it make sense or it doesn't? Again, I have no shame in saying that you guys are very shy. Yeah. Okay. So what I would say always is, keep your target a little low, outperform yourself. That should be your goal. Okay. I mean, this is what I used to tell my own daughter also. I used to tell that, okay, better do one day, come back home saying I failed, and I would want to see how we all react to it. Failing is no big deal, right? Failing once is okay. We can catch up. But yeah, as long as you are mentally prepared to get a little less score, you are actually keeping the stress away, and that will help you do better actually. That's the strategy, okay? Alright, so let's move on. So we looked at some sample problems related to quadratic equations, manipulation of manipulating quadratic equations or functions. Let's look at what do we mean or what we need to learn about the exponential functions. So we have seen a linear equation, we have seen a quadratic equation. Now I'm saying we'll not stop here. We'll go to the next step where we'll say, okay, how about this? Y equal to e to the power x, where one of the variable is actually a power to a constant, or y equal to 3 by 4 to the power 1 by x. These are the form of exponential equations, meaning where your variable itself is the exponent to a constant. Now, the value of x could change from 0 to infinity, like the way we have put different values, and then we have seen what correspondingly changes for y. Now, in this situation, what exactly happens? That's what we are trying to figure out. Yeah. So, let's pick up one simple equation, and then we'll try decoding that to understand what exactly happens behind this. So let's see if I say y equal to 2 to the power x. So this is an example of an exponential equation where one of the variables is your exponent. Okay. Now let's look at how, if I have a quadratic equation like this, I will blindly say that, okay, this is A, I'm assuming A is positive, this is a problem, facing upward. How would this equation look like? Let's see.
And again, I promise I never do anything complicated because I'm not very intelligent.
As I keep saying always.
Because the day I start pretending to be intelligent, I will only do one thing, that is getting you guys confused.
Okay? So now,
Let's look at this. This is a simple equation. We call it exponential equation based on the property of this guy. Any equation that we look at, be it a linear equation, quadratic equation, exponential equation, polynomial, whatever it is, it is nothing but a contract between these two variables.
y and x have gotten married to each other with this deal. Saying that, okay, value of y will be 2 to the power of x. If x keeps on increasing, y keeps on increasing. X keeps on decreasing, y keeps on decreasing. So that's a deal, that's a contract.
So like any other equation, we will just look at what is that is happening between x and y when the value of x and y changes. Let's say when say x equal to 0, x equal to 0, y is 2 plus 0 is 1. When x equal to 1, 2, x equal to 2, 4, x equal to 3, 9, x equal to 4, 16.
What am I doing right now? What am I doing right now?
3 will be 8, 4 will be 16, 5 will be 32.
Okay? If I say,
Let me pick,
or let me reserve it for now.
so this is my coordinate plane. We got some values. When x equal to 0, y is 1. So this is my 1 point. When x equal to 1, y is 2. Got second point. When x equal to 2, y is 4. Maybe third point. When x equal to 3, y is 8. Fourth point. When x equal to 5, y is 32. What you see here is 4, 3, this is 2, this is not going this way. Then this is 2, this is 4. 3 is 4 is probably this. So what you observe is it's a very steep
Curve, okay? Because it's a power to a natural number. It is increasing very rapidly. Now, let's look at
what happens when I put minus 1.
when I put x equal to minus 1, this becomes 2 to the power 1 by 2.
Or square root of 2, which will be square root of 2, let's say
1.414 or something.
when I say x equal to minus 2,
It becomes minus 2 or
2 to the power minus 2, which will be nothing but 1 by 2 to the power 2, or 1 by 4. Now I will play with this little bit more. When I put minus 3, what happens? Minus 3. So 2 to the power minus 3 becomes 1 by 2 to the power 3, or 1 by 8. Or this will be like 1.125, sorry, 0.125 or something. Okay?
now you'll say what exactly this old man is trying to do.
If I put minus 1, it came very close to 0. This gotten further 0. I mean very close to
Coinciding with the x-axis.
If I would have gone with minus 5, let's say minus 5, when x was minus 5, what was the corresponding value of y? So it would have become y equal to 2 to the power minus 5, or 1 by 2 to the power 5, or 1 by 32. You can imagine how many zeros it will have before it comes very close to this. Okay? So,
What we have seen just now is we had an exponential equation. We put x and y value, we assumed different values of this one, and we plotted this here. we pick the points and we plot it in the graph. What we are observing here is, in this kind of a scenario, when x value becomes, see, when we came to 3, 4, it went to 32. Imagine when you put x equal to 50, 2 to the power 50, it would have gone steep further. So a point when x is very big, maybe 50 or 100 or 200 or maybe 1000, it would have become a vertical line. That is called the vertical asymptote. When you see this line is becoming literally horizontal now. As soon as it gets closer to 0, I mean as soon as x becomes very big in a negative term, or very small number, or very big negative number, this approaches towards 0. This is called your horizontal asymptote. When the value of y approaches 0 or becomes a flat number like a straight line, that is your horizontal asymptote, and this is called your vertical asymptote, just from understanding point of view. And this kind of scenario you will come across only when you are dealing with exponential equations. So a summary of what we have seen so far is that when you have an exponential equation, we just start plotting it, and from that what we are seeing is when value of x becomes very big, I mean for this particular equation, when value of x becomes very big, y just shoots upward and becomes like a vertical line. That is, or if you want to even relate it, say okay, when x becomes almost infinity, the value of y shoots up and becomes a horizontal vertical line. After let's say when x equal to infinity, now be it infinity plus 1 or infinity plus 200, the same thing. Your y is just going, no, just takes off like the SpaceX. Okay. Similarly, after a certain point, when the value of x becomes a very big negative, y tends towards 0 or becomes constant. Okay. If I had, let's say, this plus 1, so this would have stopped at 1 and continued straight line. So when you see your curve heading, and when you don't see any value change in the y, that is when it is becoming a straight line. That's called horizontal asymptote. And here, after a certain value of x, when x just takes the y value just takes off, and it heads towards infinity, that is called your vertical asymptote. This is just from understanding point of view. Any questions with respect to what we have seen here? I'm not doing anything tricky. I'm just giving a name to these two extreme behaviors or extreme ends of the exponential graph that you see here on the board. Any questions here? No questions? Both the Chris, Dev, Sara, Prisha, Aryan, Sunarka, Rehan, Vishal. No questions. So this is just, we are just trying to kind of absorb or relate to how do you look at this one. Okay. Now let's look at few more behaviors of this one. So let me quickly see what are the things that I had put for you guys that we are going to cover today, so that I'm not missing on that. So if I, let's say, look at what does we talked about horizontal vertical asymptote, how to move horizontal asymptote. Okay. So now let's look at two situations. Okay. One is y equal to, let's say, this time I will say, let me keep smaller number, but it has to be more than 1. 3 power x plus 1, and second equation is y equal to 3 power s.
Okay, or let's keep 2 power x only, so that we don't have to plot bigger graphs here. Okay.
Now let's look at what happens when we try plotting both of them.
So when you're looking at this guy, let's pick some points. I'm talking about this guy, okay? X and Y. One gives you what value? When it's 1, it becomes 2 plus 1, 3. 2 is 4 plus 1, 5. 3 is 8 plus 1, 9. 4 is 17. 0 is, I said 0 is 1. Okay.
Now let's look at this guy.
When I'm looking at this guy, what is the behavior that we see here? 0 is 1. 1 is 2.
Wait.
Yes?
So if 0 is 1, for the first equation, 0 would equal 2, right?
Good catch.
When it's 2,
It becomes 2 power 2 is 4. When 3, 2 power 3, 8. 4, 16.
so now let's try plotting this one first. 0, 1.
0, 1. 1, 2. 1, 2. 2, 4. 2, 4. 3, 8. 4, 16.
It will go somewhere like this. Now look at this guy. 1,
3. This is 2. So it will be higher than this guy. 0, 2. 0, 2. It's here. 3. 3 is giving you how much? 2, 5. 2, 5. 2, 5. 3, 9. My drawing skills are little pathetic, so let me do some catch up here. Okay, and 3, 5, 4, 17. Be somewhere here. What I'm trying to depict here is this.
what you see here is when you have a constant added to this one, what is happening to this? You can very well see this, right? When this is turning out to be 0, you're still starting at 1 point above. So this constant helps you shift your function up or down. Yeah. I'm scratching my head. I want to see who all are scratching their head as well. What you're trying to understand is, how does this thing work? How do I manipulate or move the exponential graph formed by exponential equation by use of the constant? And what we saw just now is that when I have an exponential equation and I add a constant to it, based on this value being positive or negative, the graph is moving up or down. If you put a -2 here, you will see that your graph moves this way. If you move +3 here, you will see that your graph moves this way. Yeah. So, and again, this is not what I'm trying to inject into your brain by putting any complicated concept. I'm just trying to see how I can visualize this by putting simple, different values for x, and see what is the corresponding change in y, and how do we see the behavior changing here. Is it making sense to you guys, or getting you guys more confused? So Vishal said that he's okay. Sarah, Sunaka, yep.
Makes sense, sir.
Makes sense. So again, whatever we learn in the class, there are two ways of this becoming yours. One is practice. You learn one concept in the class and don't believe your teacher. As simple as that. Says, okay, fine, teacher did his job of explaining me the concept, but I would not believe him because he keeps saying don't trust your friend. So let's say if you assume me to be your friend for that 1 hour, whom you have been forced to believe, don't believe me after the class. And then say, okay, fine, let me do it myself and see, try solving few problems and see if whatever this old man said, that is making sense or not. Can I agree to his point of view? Okay. When you do that validation, you would be able to make that as your concept. That is one. Second thing is, whenever we are trying to do that in a simpler way, right? The whole intent is that at run time, for any problem which is little complicated, okay, which sounds little complicated, right? Exponential equation, I don't think I would ever feel comfortable just by reading the question. Unless I do some scratch work or plot it, trust me, it gets me scared. Okay? But as soon as I read a couple of times and then I draw it, complexity level keeps on going down. So I want you guys to practice the same thing. That okay, whenever you have a problem to deal with, plot it first. So all that we are learning now, whether it moves upward, downward, sideways, you don't have to memorize anything. Do quick scratch work. See, because there will be questions that you'll be able to solve very quickly, okay? If you look at any SAT exam, if you have, let's say, 40 questions to answer, there will be 4 to 5 questions like this, where you will not be 100% sure. Park those questions for the end, and when you come to it, you'll have enough time because you have run through all the other questions that were much straightforward, and then you came to this. You have saved some time for yourself, where you can afford to kind of plot it and spend 1 minute extra. Plotting this will not take much time. While I'm trying to explain this to you guys, it's taking time. But when you do it for yourself, you would not spend that much time actually. So that is when this organizing your time and then kind of plotting it and doing it will make it much easier. Okay? So with that being said, I'll stop here. Sit down, it's okay. I mean, they will enjoy some tough math for a couple of minutes. That's okay. So I would certainly want you guys to always practice a lot of problems. Not a lot, but at least good enough to reaffirm what we learn in the class. You're able to apply that in your own way, basically. Yeah. Any questions before I let you guys go? Or we have 5 more minutes, so sit down. You guys have to just relax, keep breathing, keep meditating for yourself so that you get charged up for the class after 5 minutes.
The kid didn't come today because he's with my dad.
Okay, that's fine. He'll have to watch the video of the class later on so that he
Only
can.
on YouTube.
That's the only way.
It's not.
Yeah. So any questions? No questions? No doubts? Not a good sign. Any feedback? Let me put it this way. And trust me, your feedback matters to me because that's the only way I can become a better teacher. Okay? If you guys, yeah.
Does the vertical center truly become vertical, or is it because there'd still be some
So vertical asymptote and horizontal asymptote, these are like virtual scenarios. These are not real scenarios. This says when it is tending towards infinity, when x comes very close to being equal to infinity. Now, equal to infinity, what does it mean? Yeah. Here, I'm saying when x becomes, see, let's look at this situation. When I say x becomes almost a very big negative number, when x equal to minus 3000, it will become
1 by 2 to the power 3000. And you can imagine this number being how close to 0. But which number will make it 0? We don't know. Right? 3000, it might come so very close to hitting the x-axis. But then still it might be like 200 zeros and then something, which is as good as being called a 0, but technically can we call it 0? No. So when you look at horizontal and vertical asymptotes, these are the extreme conditions or situations when it is about to hit. Okay? It is like getting a perfect 800 in a city. 99% of the students will get as close to getting 799, 795. Hitting 800 gets little delusional at times. I'm not saying that you will not get it. Sit down, sit down, sit down. You will not get it. What I'm saying is, it gets so very close to it that it gives you a feeling that it is that infinity. But what is infinity? Positive infinity or negative infinity? Trust me, in my lifetime, I would not be able to see how does it look like. Yeah. So it is just a situational or co-relational thing which says, okay, fine. If it gets close to this is what you will see. Otherwise, you will keep seeing, okay, depending on how great your drawing skills are, you'll assume this to get close to it. That's all. Yeah. So the question was that horizontal and vertical asymptote, does it get close to 0 or does it become a vertical line? I'm saying that this line keeps on becoming, the slope becomes as good as becoming a horizontal line, but never becomes horizontal line. It just gets very, very close to it. That's it. Yep. Are you guys with me? Okay. Alright. So I will let you guys go. Enjoy the rest of your evening. See you guys tomorrow, same time. And I will publish what are the things that we are going to cover tomorrow, because we covered whatever we wanted to cover today. So we'll see what are there in the reserve for you guys tomorrow. Yep. All right.
Thank you, sir.
Yep. All right. Bye bye. Bye bye.